All right, so we're going to take a look at 10.4 today, which is called Pascal's triangle. And I want to first talk about what Pascal's triangle is. This is an unending triangular array of numbers written by a mathematician named Pascal, 1653. But there's evidence that shows it was studied from China and India as early as 1100. So this is a very old convention, been used for quite a while.
Just let me jot this down.
Mm-hmm. Notice on your paper you've got a really big blank space if you've printed this out. You're going to need that big blank space, not for this 4 lines of text. You're going to be drawing in a triangular array, as it describes. In fact, you're going to draw in 2 triangular arrays. The first one is the Pascal's array, and then the second one is how it relates to combinations. Okay? Okay, are we good with this slide? Almost?
Yes.
Not yet? Okay.
Just frustrated.
Okay. Are you almost finished with this one, Leah? You're going to start on the left-hand side, and we're going to write row number, and then we're going to write the row sum on the right-hand side. And oddly enough, we're going to start with what I'm going to call row number 0, and I know that doesn't really sort of jive with our idea of counting, but based on what the things are that we want to do with it for combinations, it's going to make more sense to call it that. So this is row number 0. Right in the very center of your screen, you're going to put the number 1, and then that is the row 0. It has 1 number in it, and it's the number 1. And then that means the sum of 1 with nothing else, of course, is just 1. Now, I'm going to leave the row sums to the very end. I just was to fill that one in. But our row numbers we're going to fill in as we go. So this is row number 1 now that we're starting. And what we're going to do is we're going to put a 1 on either side of the one we already have. So it looks kind of like they're sort of at a diagonal from where we were. Okay, they're not supposed to be directly underneath it. It's supposed to be a little bit off-center. So it looks like the 1 on the top is occurring halfway between the 2 ones below. All right, this is row number 1. Row number 2 has, again, 1s on just the outside of the 2 ones that we already have. But directly underneath the first top one is going to be the number 2. And I'm going to fill in about 3 more, maybe 2 more rows before I show you where these numbers are coming from, and then it'll make sense and we can fill in the rest of them from there. Okay, so right now this row has 1, 2, 1 on it. Okay, again, it's all off-center from the row above it by, half of a number or whatever, half of a spacing. All right, row 3, again, it has 1s on the outside edges, and it has a 3. It's not a good 3. Let's try again. Here and here. So these 3s here are lining up underneath those 2 1s, right, off-center from the 2. We'll do 1 more row, and then I'm going to talk about where all these numbers are coming from. All right, so here's a 1 again on either outside side, so the triangle's becoming very clear, right? The numbers are being built down as we go. We're creating a triangular array of numbers. The number between here is a 4, and then a 6, and then a 4. Okay. So here's this 4, again, directly underneath the 1, 2 lines above it. This 6 directly underneath the 2 lines above it, and this 4 directly underneath the 1, 2 lines above it. Okay, is everybody good so far with having this written down? Again, I'm going to save the sums until the end. We'll talk with them in a minute because they don't really affect the arrangement of the rows. They just have a really nice pattern to them we want to talk about. All right, so where are these numbers coming from? Well, let me show you that with row 5. All right, I'm going to start the row on the outside with the number 1. Now, the number that goes right here next after the 1, what it actually is it's the sum of the two numbers above it. 1 plus 4 is 5. And if you go back up in the table, that's exactly what happened before. For instance, this number 6 is a 6 because this is 3 plus 3. This number 2 is a 2 because this is 1 plus 1. This number 3 right here is a 3 because this is a 2 above it and a 1 above it. Okay? So what would be my next number after my 5? 10, because it's a 4 and a 6 above it. And then after the 10 would be another 10, right? And then a 5, and then another 1. So there's wonderful symmetry involved in this whole array, isn't there?
Wow.
Once you get half of it done, it starts repeating on the other half of it. Okay, let's see, I have written down till row 8 on mine, so hopefully yours will be large enough to do it. I don't know if mine will. We'll see. Row 6, I've got 1 and then what? 6, 15, 20 next, actually, 20 because it's a 10 and a 10, and then a 15, 6, and 1. Let's do row 7. I start with 1, and then I have 7, 21, 35, another 35, a 21, and a 7, and it always ends in a 1. We'll do one more row because I think we need it for some of the problems we're going to look at. Okay, row starts with a 1 because that always starts that way. And the cool thing is, what do you notice about the next number? What is it first?
It's not always this.
It's always the row number. So the next number is an 8 because it's 1 plus 7, but it's always matching the row number, which is part of why we want the row number to do this, right? That's why I started with row 0, so that I would have that kind of nice feature involved, and it would work nicer for some of the other problems in interpreting. So this does give me an 8 next. Then what? 28. Is it 56? 56, good. And then 70. Okay, so mine is running out of space for my row sums over here a little bit, so I'm going to kind of do this, and maybe I'll move my row sums over. Maybe I'll do that. Maybe that would be easier. Let's try that. I'll write my row sums on the very far right-hand side. All right, so this is a 1. I want you to look at actually row 1. What is the sum of row 1? It's 2. If I can keep my lines across here, sort of, right? There's a 2. What is my next row sum? I have a 4. And then it is an 8. And then, is anybody noticing a pattern? What's the next one?
That's the double.
Yeah, it's doubling every time, isn't it? 32. What's the next one, or what should it be without adding? It should be 64, and it is. Good. Right. So there's a nice doubling feature over there on the right-hand side with those row sums. Not only can you do it, hang on just a second, Leah. Not only can you think of it as doubling, you could also think of it as powers of 2. These are all powers of 2. That's what doubling does for us. So the first one is actually 2 to the 0 power. And this is 2 to the 1. And this is 2 squared and 2 cubed all the way down. So you can think of it as powers of 2 when it's more convenient to think about it from that perspective. Did you have a question, Leah?
Well, mine isn't exactly symmetrical per se.
It should have the same numbers to be symmetrical, and that's what I mean by the symmetrical, right? So is that the numbers sort of repeat once you get to a certain spot, you have a repeating digits on the other side. That's what we want to have happen. Now, I want to show you what happens with combinations. That is, how is this idea related to what we're doing? Because, I mean, that's wonderful, but that sort of almost starts to look a little bit like geometry, doesn't it? I mean, and I love geometry, so that makes me happy. But I want to show you how it relates to combinations, because that's, I'm seeing some no. You don't love geometry? Oh, man, we got to talk later. All right, so we're going to look at those row numbers. I want you to write row numbers, and we're only going to go down to row 5, okay? because you'll see what's going on by then. So write row number on the left, just like we had before. 0, 1, 2, 3, 4, and 5. And we're actually going to write the same kind of an array. It's just not going to have specific numbers in it. It's going to have combinations in the array. So very dead center of your page or whatever, on row 0, this is actually 0C0. Okay, so from a combination perspective, it sounds kind of funny. I have 0 things to choose from, and I choose 0 of them. And how many ways can I do that? One way, actually, right? It's not a very exciting way. It just means I sit in my dorm room and do nothing or whatever, right? I mean, there's nothing to do, and I do nothing. One way to do that, right? Okay, so now let's move on to the next one because it starts to look a little bit more interesting. Again, we're moving out from there, catty-cornered, right? Just like we did with the ones on the second line of the rows before. It's called row 1. I'm going to have 1C0, and then outside of that, I'm going to have 1C1. Okay, so let's fill these in, and then we'll go back and talk about how they relate to what we did. On the second row, it would be starting with the number 2. So this would be 2C0. In the middle, directly underneath the C0 is 2C1. And on the outside is 2C2.
And it's looking a bit scaling.
They do. That doesn't matter. That's not the issue. Okay, so there's more to write, so that the writing gets a little bit trickier. And I probably should move mine down a little bit, too, to have myself some more writing room. Okay, so this is row 3 next. Whoops. So it starts with 3C0 on the outside, right? And then directly underneath that 1C0 is 3C1. And then I have 3C2. And then I have 3C3 on the far outside. Okay, row 4 is going to start with 4C0. And then directly underneath the 2C0 should be 4C1, and underneath the 2C1 should be 4C2, and then 4C3, and then 4C4. And the last one that we're going to do for right now is going to be row 5. And row 5 is going to start again with 5C0, right? They all start with the number that they're on the row for, C0.
Oh, dear. Now what?
And then we increase one at a time. 5C1, 5C2, 5C3, 5C4, and I'm barely squeaking by with enough space over here to do 5C5 on the outside.
Look it. I didn't make a triangle.
All right, so the structure matching up actually is better than just, oh, it just has the same number of things on each row and column or whatever. There's more to it than that. Here's the cool thing. Let's say, for instance, that you wanted to know what is 4C1. Now, you guys know what 4C1 is. It's 4. We've done that before. But here's the cool thing. What row am I on? 4. I'm on row 4. And which entry am I at? It's the second entry, right? The second entry. So fourth row, this number here is 4. This is one less than the entry I'm actually on. I'm on the second entry, and it says C1. I mean, I get that. I'm one less. But this is 4C1, second entry on the fourth row. Go back to the second entry on the fourth row over here. It's a 4, isn't it? And it happens that way every single time. Okay? You can match it up. So if you wanted to know what is 5C3, well, look at this. I'm on the fifth row. I'm in the 1, 2, 3, 4, one more than this number. Fourth entry on the fifth row. I can go over here and go to the fifth row. Fourth entry, 1, 2, 3, 4. I'm at the number 10. So 5C3 is number 10. Okay? So there's a pattern recognition for that. And that's exactly what we're going to be looking at in this section. Okay? So we're going to read these numbers. And I realize that I stopped just shy of row 6 on this, didn't I? I didn't do row 6. And the first problem that you see on the next page says 6C3. Okay? So let's talk about what this means. What does 6C3 tell you to do, Pascal triangle? What row am I on? Sixth row. So this is the sixth row. what entry is this? Fourth. It's always one more. So that C3, that 3 down there at the bottom, it's not the third entry, it's the fourth entry. So this is the 6th row, 4th entry. That's what 6C3 means. So we're going back into our table over here. 6th row, 4th entry is 20. So 6C3 is 20. Yes?
How do you want us to write that? Do you want us to, like, if we see that on, like, the test, do you want us to just write the number, or do you want us to write, like, 6th row, 4th entry equals 20?
You can write 6th row, 4th entry equals 20. That's a great way of showing your work. The other thing that I could ask you to do, and this is something I have done on a test before, is actually ask you to create a portion of the table and then go back and do what I'm doing on this picture, which is to box in the entry that corresponds to it, which would be doing the same thing as writing out 6th row, 4th entry. Yeah. So either of those would be great ways of showing.
To write out 6th row, 4th entry.
You can,
You
yes.
can't just write 20.
You can write 20 in your homework, that would be fine, but you need to know where that 20 is coming from. So if I asked you a question that says, how am I going to use the table to do this, you'd be able to answer me 6th row, 4th entry. Does that make sense? All right. How about 8C6? What is this? 8th row, 7th entry. And what is the 8th row, 7th entry? Is it the 28? Yep, 28. 28th, right?
The entries are one greater than the row.
They are. Whatever row you're on, it actually tells you that with the first number, right? And the entry you're looking at is always one greater than this one. So jot that down if you'll want to remember that later. Now, we're going to use that idea with an actual problem now, okay? So it says, also notice, what kind of operation are we using, combinations or permutations with this? This is a combinations feature, okay? So this doesn't work at all. It does not help me in the slightest with permutations, okay? But for combinations, it gives me another sort of a feature or a branch of mathematics that you can see a connection with, which is what we're looking at, really. All right, so it says, suppose a committee of 3 people is to be selected from among 7 women and 3 men. Find the number of ways of obtaining each result. All right, how do I get exactly 3 women?
7C3.
Right, there are 7 women to pick from, right? Okay, the 10 has nothing to do with how many ways of picking just the women. Right, there's 7 women, 3 men, so there are 10 people total. I agree. But I want to only select women in this particular problem. So there are 7 women, and I need to choose exactly 3 of them. So thinking back to the Pascal triangle that we were just working with, how do I use that? 7th row, 4th entry. And what is the 7th row, 4th entry from this table? 35. Now, how could you check to make sure you got the right answer? You could work it out, right? You could verify it to make sure, especially if you ended up with, and some of you are really quick test takers, not everyone, but some of you end up with time at the end. I know, half of you are gone by the time half the test is over. So you could go back and you could actually check on that scratch piece of paper next to you, make sure that you actually got the right entry, right? And if you didn't, you could probably use that information to figure out which entry it should have been, at least with some degree of accuracy. Agreed? Okay. All right, let's take a look at another one. Now we want exactly 3 men. How am I going to do that? 3C3. There are only 3 men, and I want to choose all 3 of them. Now, you probably remember from last time. If you don't, it's okay what 3C3 is. But let's think about it from the triangle's perspective. What would I be doing? 3rd row, 4th entry. And what is the 4th entry on the 3rd row? 1. Now let's think about that. That should make sense. There are only 3 men, and I need to select all 3 of them. And if the order doesn't matter, there's only one way to do that. I got to pick a man every single time I pick someone. Okay. All right, how about exactly 1 woman? How's that going to work? All right, 7C1's a good place to start. That gets me my 1 woman. But I need somebody else in this committee. How many people are supposed to be in this committee? There's supposed to be 3 people in the committee, so if there's exactly 1 woman, there's 2 others, and they're both men. So how many men do I have to pick from? 3, and then I'm going to choose 2 of them, so 3C2. Okay, so let's do this the same way. So this is the first one is the 7th row. What entry? 2nd entry.
Third entry.
The 2nd entry on the first one. We'll get the 3rd entry in a minute. So what is the 7th row 2nd entry? That's 7. And then for the men, the 3C2, what row? 3rd row. And then that's the 3rd one, the entry, 3rd entry. And what is the 3rd row 3rd entry? There are 3, and 7 times 3 is 21. I don't know about you, but it's kind of nice to not see factorials all over my screen today.
Yeah.
Okay? I mean, this is just kind of a little bit of a reprieve from that notation. All right, we have one more. Exactly one man. So very similar to the last problem. How do I do that? 3C1, that gets me my one man. 7C2, looks good. All right, so 3C1, what is that? It is 3. It's the 3rd row, 2nd entry, right? That's the number 3. How about 7C2? What's that? 7th row, 3rd entry. And what is the 7th row, 3rd entry? 21. What is 3 times 21? There are 63 different committees that could be formed of that variety. Now, before we pause for group work, let me make one observation. When it comes to a test, you get to use something on the test. What are you going to use? A note card. What might you want to put on a note card? It might be a good idea to put Pascal's triangle on there. And you can either do, and if you write it small enough and or have enough space, both versions might be helpful, or at least a portion of this, right? Do I think that you need to go down to row 8? I mean, it's up to you how far you go. I mean, but if I ask you about row 9, you still don't have all of it there, right? Could you recreate row 9 if I asked you to right now? Yeah, you should be able to, right? How would you do it? Yeah, you're just adding the numbers that are at diagonals above each value, right? So that's how we could recreate row 9, and we could continue on with this pattern indefinitely. Agreed? All right.